Okay guys, we're back again. It's a slight interruption. So I've got that first one stripped off. See, now when you actually strip it off, just double check that you haven't nicked the inner insulation, which is the green, the blue and the brown. And you do that by just prizing it open a little bit like so, and just having a good inspection of it. And once you've determined that you haven't done that, that's fine. Then we'll get on to number two. So we can put that to one side now. We've got the number one stripped ready to go. We'll strip both of them before we even start putting the ends on. Okay, so now we measure off number two, which is the 438 3-pin base. And we lay the end of the conductor right where the end of the copper wire should be. And we just put a mark, we put a label or a mark with a pen. I'm using my thumb and I just gradually just work my knife around. The knife is sharp, so it's going to penetrate quite easily through the outer insulation. So be aware of that. And just work your way around the insulation like so. And it helps if the insulation is a little bit hard and it doesn't bend too easily, because you'll see why in a second. So now I've done that, I can just go like that where I've nicked it, and it just breaks off nice and easy if it's relatively stiff. If it was soft and easy to move, well, that would not do that. I'll have to penetrate the knife more. Okay, I've got both the ends done. I'll make sure I put the knife back in its closed position so there's no sharp edges laying around. I've got both ends done. The next thing I should do is actually put both the nuts on that end and the nut on the other end. Now you can strip the cable first, or you can do that first, doesn't matter either way. Check the wire strips, make sure that the jaws line up correctly before you use it. And you don't need a lot of conductor off, because these terminations are quite small, so you don't need a lot of conductor off to be able to complete the termination. I'm taking about 10 millimeters off the end of it. Okay, got all that done. Now I'll feed the outer cover of both ends on. You can just do one at a time, doesn't matter what order you do it, but just don't forget to do it, that's all. It's the important thing. And I just twist the conductors up with my fingers. And just make sure you get the polarity right. If you need a hand with polarity, the actual polarity is in the back of the drawing of this particular cover for the plug top, and gives you an idea about what should go where. What also is important to realise is that these different plug tops, this male pin also has the S means the safety, which means that the active and neutral pins have the little bit of insulation on them, so when you do pull the plug top out of a power point and so on, if your fingers slip down behind, you don't get an electric shock. So that's mandatory now, that all plug tops on new leads and so on have this type of plug top on. The other thing to remember is also, if your eyes are good enough, you should be able to see in the back of the insulation there on the plastic insulation an A, an N and an E on the actual insulation. But for memory, if you're looking behind the plug top like so, the active pin is always on the left, looking from behind, the neutral pin is always on the right, and the earth pin's on the bottom. If you're looking from the front, it's obviously reversed. The active pin is on the right, the neutral's on the left, and the earth pin's on the bottom again. So I generally look at it from the back. So look at it from the back, I make my conductor nice and tight, I bend it over so I've got a good connection, and then I just put it in the slot, like so. Do I do that again? Bend it over nice and tight, and I just put it in the slot like so, so that the, I'll do that again because I've actually doubled it over, pulling it out first time. I push it in nice and tightly. I don't want the insulation to go under the screw, so I've got to make sure I don't push the insulation into the termination, just the copper conductor. And I do it up with my flathead screwdriver. Just make sure that's nice and tight. Just give it a little pull, just make sure that it's not going to come out, and you move on to the next one, neutral conductor. Doesn't really matter what order you do these in, you're just going to make sure the wires aren't twisted, because they have to go over these little clips here, to help support the connection. So when the cord is pulled, you don't pull the wire out of the termination point. But we'll talk about that in a second. I've made a bit of a mess of that. One of the conductors didn't actually go into the hole properly, so I can see a little bit of copper poking out the bottom there, so I've got to fix that up. That's very easy to do. Anybody can do that, an expert can do that, and a novice can do that. So don't beat yourself up if it happens to you, just make sure you pull it out and do it again. So it isn't done like that, so that all the conductors under the termination. And you'll find in the insulation of the actual conductor, there's a fine powder which actually goes around the outside of the conductor between the inner conductor and the sheath. And that powder, believe it or not, makes everything very slippery. So just be conscious of that. And take care, don't rush. Nice and secure. Onto the earth conductor. Just making sure those are nice and tight. Okay. Now, if you see what I mean before, you see now that these little fins here on the outside, the conductor's got to go over them. So you just very gently put a bend in the cable and go up around like so, and clip it over the top like that. You work your way around, go to the next one, put a little bend in the cable so it's not putting pressure on where you've terminated the wire under the copper or the brass sheath, the brass connection point, and go around to the earth conductor. You should have enough on all of them to do that. It'll be a little bit tight on the last one because you've actually made the cable spot on length, but it should go over that without too much of an effort. Like so. And your conductors will look like that. From the outside, from behind, and from the side, like so, and like so. You just inspect it, just make sure there's no copper floating around, or not terminating the correct under the termination screw, just make sure that's okay. Once you've determined all that and all that's okay, you can then push the plug top into its outer sheath. Now you find that that plastic is quite hard, and there's absolutely no way that I have the strength to push that all the way into that. They've actually changed the insulation qualities of the outer sheath quite a bit over the years. So there's two ways to doing this. Well, there's probably more than two ways, but there's many ways to do this. So one way to actually solve that problem, to help your sister do it, once you've pushed it in that far, is to go around to a point where there's no copper, which is this point here, and just give it a little crimp to get things started, and just work your way around slowly, give it a little crimp. Don't be too fierce on it, just nice and gentle. And you see that is actually clipping into position. Once you've got so much started, what you can actually do then, and you have to be careful you don't pierce yourself with the screwdriver, but what you can do, also, if you wish to, is you could actually use the heat gun, put it on setting 4, and just give the bucket a little warm, like so. That softens the outer insulation. Don't get it too hot because you don't want to not be able to work with it. Take your time. Don't get the gun too close to the plastic because it'll burn it. When you put the gun back down again, just make sure that the hot end of it doesn't touch the rubber surface. And now that that's nice and soft, I can actually push that in there with my fingers now, and it'll clip over the edge. Couldn't do that before because it was too hard, but now I can. And there we are. See, it's clipped in position all the way around. You look behind, all that's good. Give it a little pull, just make sure that's sitting properly, and it is. That's good. We now put the nut, because it's fallen off the other end, of course, and we put it on there. And what we do is we now screw that just by hand onto the end of the outer sleeve of the plug top until we see that that's gripped that tight and it's gripping the cord down inside. But with the cord should be visible, the outer sheath of the cord, which is just grey, should still be visible inside that above the nut, so to make sure that you know that you've actually still got the double insulation inside the connector itself. Okay, that end's done. Move on to the second end. Nut first, outer sheath second. Obviously, be conscious and make sure you put both on the correct ways because they've got to go back in the opposite direction. And we actually make sure all these screws, before we try to push the wires inside them, that the screws are out far enough so the copper conductor can go inside. Don't undo them too far because they'll fall out. But that's okay, you just make sure that you still just see the bolt on the inside of the brass sleeve inside, so that the copper can go underneath it. Quite often when they're in the packets they screw them 3/4 of the way in so they don't fall out. Now the golden rule of thumb, and I didn't say it's with the plug top, but the golden rule of thumb with all terminations is we generally terminate the most important conductor to start with. And the most important conductor, both in AC and DC terminations, is the earth wire. So in this particular case, I didn't do it with the plug top, I just terminated any wire in any order, that's fine. Nothing wrong with that either. But it's good practice to make sure that you terminate your earth first and disconnect it last. And the reason why it's good practice is because that protects you in case somebody else decides to energise something that shouldn't be energised while you're working with it, or it hasn't been locked out correctly so people can't energise it behind you. So I put the earth conductor in first. It's not muscle. Getting it tight is important, but you're not trying to break the head of the screw. Good firm termination, that's good. Now in regard to the other two conductors, it doesn't really matter. Once again, we don't want any twists in the wire. So as the cores come out of the outer sheath, you'll see they lend themselves to go in a certain order, and you just follow that order. There's no right and wrong in that, and what one goes next is just how it comes out of the flex. And because the flex is twisted, it can be any one of those scenarios in regard to what conductor comes next in the termination. In this case, I'm doing the brown, which is the active. Just a termination again, that's good. I'll work your way around again, and the last one is the blue, which is the neutral conductor. This will be quite tight. Just make sure you get it all lined up properly before you try and force it in, because you don't want it to fall out and you don't want it to miss the termination point. Just make sure that the wire tight enough. Now I've doubled it over again because I want as much conductor under the screw as I possibly can, rather than just a single core insulation. It's actually doubled over so it has a better bond to the termination point. Okay, that's in ready to go. termination again, that's good. Check all through, make sure all through good. Now you'll see in this particular case, there's little grooves where the wire is to fall inside, so it doesn't actually put any pressure on the conductor. So now we put all the 3 conductors inside that little opening in the base, so that allows the conductors to go where they should go. You want to twist the conductor a little bit, the outer sheet, so that the wires will fall into where they're supposed to go. But if you follow the directions of the length of the conductor, they should be tight, but they'll be snug and they'll fit well, and you should end up with a termination like that. Work your way around, see that's hard up against the base. Conductors are in there, there's no copper showing, and it looks nice and smooth. Okay, so now we pull the plug top on. Now this is a little bit easier than the 3-pin base cover on. This is a bit easier than the plug top because it slips in slide a little bit easier, but the top clip can be a little bit tricky. So you push it in, don't put any major pressure on, don't pull that enormously or overly strongly, because you'll find that that will put extra pressure on termination. But you can see that I've pushed it in there with hardly any effort whatsoever. And what you'll see is that any clip clips into the outer ring of that. I've made no effort at all, didn't have to heat it or anything. And now that I screw that up, like so, I can see the inner part of the outer cover at the back end of the nut. I can see my inner insulation, and my double insulation is also visible above the nut, and I now have a cordon plug complete. My next job will be to test that, and the tests that I have to complete according to the practice are a continuity test and an insulation resistance test. Now the continuity and insulation resistance tests for the cordon plug are actually in the same Topic Skills Practice, but they go back to the Topic Skills Practice 4.2 section 2.31, and where you will use a multimeter to do the continuity test, and then you'll use an IR tester or an insulation resistance tester to make sure there's no short between the conductors. So we'll have a pause and then we'll get to that.